Hello, my name is deferent, and I'm going to talk about one of my favorite subjects, subwoofers. There's a lot of interest in different subwoofer setups, so I thought I'd talk about stuff that works and doesn't work, different applications, and some of the aspects of subwoofer setups that are generally overlooked. Conventional sub setup. There'll be subs on the left, subs on the right, stage in the middle. It's just kind of your basic go-to starting point. There's some major issues with this setup. Primarily, this is in Meyer map simulation program. And these programs, there's various programs out there that simulate what subs are supposed to do in these setups. And actually they work quite well, but there's some caveats to them as well. As you can see, what I call the butterfly, we have power alley in the middle, the two power valleys. Here it will be power alley in the middle. The two power valleys just either side, and then off to the sides, not a whole lot goes on. Let's say you take 4 subs and put them in a ring, point source-ish type setup. What you have here is you'll get pretty much a hemispherical coverage. Whenever dealing with subs, one real good way to think of it is equidistant. Wherever you're equidistant from the most amount of subs is where they'll be the loudest. With 2 sets of subs, you'd be, if this one's on, you'd have a power alley down this point, another down here. You turn them both on, then you get a new one down the middle. And the power valleys are caused by, it's the area where they're close to the same volume, but you're off center. People have started to increase coverage as you take and start to point these outward. Now, these primary summation points are off to the side. You've widened your power alley, you've reduced your power valleys. One of the issues with that is your stage being here. Now you've started to push the barricade out, disconnect the performers from the audience. Another common setup is setting subs up across the front of the stage. This is interesting because it eliminates your 2 null points, because now you have a common center point. Your power alley is still there, and it'll fade as it gets to the side. You still have your issues off to the side. And if you look at your coverage point, you now have pretty much part of a wheel. Your coverage point vertically goes up. You still have significant energy hitting the ceiling and significant energy hitting the band. Change these to cardioid subs. You reduce that. Your vertical stays quite good, less hitting the ceiling. But you've still got major issues to the sides. Your width is not that wide. Take it to the next set. We start to look at forming an arc. An arc is an interesting setup because now you've increased the width of your coverage out front. You don't have your power valleys if it's continuous. But look at your focal point. Where are you equidistant? You're equidistant from the sub, probably somewhere right on stage or behind stage. You now have the summation point where all the subs hit you at the same time. This is a significant issue. Like the ring pointed up, this arc has a primary focal point behind it, and its coverage gets wider as it comes out and comes back in narrow. You have a significant amount of energy hitting the ceiling. Again, less than desirable. Using cardioid subs, again, you can bring it in, but now we go back to the other problem again. We have the issue of pushing the barricade out. Now you've got the band disconnected from the audience and this big dead space here between the band and the audience. And you still haven't resolved. This still doesn't solve your coverage off to the sides. Improved, but not solved. To deal with one of those aspects is to do a delayed arc, to create a virtual arc of subs where you set them up in a line. Let's say we use cardioid subs to reduce the coverage behind. You have these at 0, these slightly delayed, these delayed more, and these delayed more than that. This then would widen your coverage. It solves the barricade distance problem. So let's take a look at comparing mechanically arced subs with electronically arced subs. And I'm going to start by going back to the point source. With a point source, or a single area where all subs are putting out sound at the exact same time, no time delay, no phase alteration, this puts out a uniform circular hemispherical waveform. comes out in all directions. When you do an arc and everything is at 0 time, it puts out this nice curved waveform. Each sub, when this speaker is moving out, the one next to it is also moving out at exactly the same time, and they're all working together in unison. With a delayed arc, it's a little bit different. So physically, they're in the same plane. The center subs put out the sound first. These put out sound a little later, these later, and these later than that. So from this perspective here, these subs are closer to you and incrementally farther away. Another interesting aspect to this is, let's look at it with just 4. So it's got the virtual sound of that. If you go up above it, it's got the virtual sound of that, where the ones in the center are closer to you, the ones that are on the sides are farther away. When you go behind it, it's got the sound of that. Again, no matter where you go, the center ones are closer to you, electronically closer to you than the rest. I got a little test rig set up to show you some of the side effects. Now, I'm going to set this up in a mechanical arc, but this will be the delayed arc. And let's say that these two are at 0 time, these two are at 2 milliseconds, these are at 4, and these are at 6. Now, with the actual delayed arc, it would be slightly different. Here's my setup. I've got a laptop that is acting as my sound source, and I have that going into a 1-in, 4-out delay. I've got a towel wrapped around it because it's noisy. And out of that, the 4 channels go into this ancient mixer here. I like to use old gear. I like to demonstrate on the most simplest equipment possible to show you that you can do this at home. I've got a tone coming into it right now that is 46 cycles, 0.78. You could use 50. And that's at 0 time. We can see it on the scope. That's at +2 milliseconds, +4, +6. As you can see, they all sound the same. And you should be able to hear that they all sound identical. And those are run into this, currently just this speaker. Now, I'm going to bring up 2 at the same time. And 3. My board's old. So, 1, 2, 3. And the tonality doesn't change. Now keep in mind that these are all set at different times, and I can show you that as well. We can send these over here and take a look at both waveforms. So here we can see 0 milliseconds, +2, +4, +6. And regardless of which ones I bring up, the tonality doesn't change. The fact that the sine wave sounds the same regardless of what we're doing is very important, because that is primarily how most of the prediction software determines what your sub coverage is it looks at what a sine wave would do in that environment. But if you take something other than a sine wave, and for this I'm going to use a kick drum. And this is cool. I went to freesound.org and found a kick drum sound. These speakers don't do a whole lot, but there's, and we can look at our waveform there. And you should be able to hear that and get a good idea of the tonality of it. And put them all in the same speaker. And as you can see, they all sound the same. Now here's where it gets interesting. That the output of these center subs, will combine acoustically with the output of these subs, which will combine acoustically with the next ones over, and so on. The fact that their waveforms in the open air acoustically couple so well and or interact so well allows them to be steered. That's what we depend on in order for a delayed arc to work. If they didn't interact well, the delayed arc wouldn't work. So what I'm doing is I'm going to electronically sum these outputs instead of acoustically. Now I electronically sum them with the sine wave. Watch what happens when I electronically sum them the kick drum sound instead of the sine wave. And listen. I'll try and keep the wave about the same. I'll turn it up a little. Okay, so there's all four. So basically, if you were out here in front, somewhere in the summation pattern of these four delayed subs that were electronically delayed to make the shape, that's the sound you would hear. But listen to that compared to the original signal. Now that should transfer over even to the crappy mic of that camera, and it was a pop, 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 kind of a punchy. It had some of the upper frequencies of the sub range involved, and as I added more and more of these electronically delayed subs, it became deeper and less dynamic sounding. It kind of goes flow, 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 flow. That characteristic, I mean, it's easy to test. You set your subs up in a line, you start inputting the delays, and all of a sudden, all that punch has gone away. You don't notice it with pink noise, but with a popper, a tester, some sort of asymmetrical signal similar to a kick drum, it becomes readily apparent. The interesting thing is that it's not taken into account into the prediction software. The whole idea that delay arcing completely alters the sound and the dynamics of the low end. Now you may have thought of it, or to be able to actually recreate this and show it was it took some thought, but I'm pretty excited about it.